Hello friends, welcome to Science with me. My name is Dr. Erica. I am so excited that you are joining us. Please make sure you subscribe to our YouTube channel if you enjoy our science projects, and you can always support us at patreon.com/rosieresearch. And we are working on Nobel Science, a unit on it. We're going to learn all about the people who are behind the Nobel Science. We're going to learn about some of the Nobel Science. And over the next 2 weeks, every project you do, you can get a slice of a Nobel Prize. And then at the end of our unit, you'll have your own fun little Nobel Prize. So today we are going to look about the Nobel Prize of 2012, which was about quantum computing. Now, quantum computing is huge. It's mind-blowing. And what it does, instead of using little tiny magnets that go up or down for being in a state 0 or 1, it uses something called qubits, which are subatomic particles that could either be up or down, or kind of actually maybe partway up or partway down. And it could be in any state of that until we collapse the state to find out what it's in. And this has huge implications for computing. So one thing is, like, instead of doing 200 million calculations per second in a computer, a quantum computer could do like 1 trillion. That's a lot. Instead of spending thousands of years to learn for AI learning, it could learn all of that in a few seconds. Or it could store massive amounts of information. Massive. You could take 4 pictures a minute for the rest of your life at like full high quality resolution, and it could store it on just 50 qubits. So just 50 of these, if we put them together, can do a huge amount of things. So we can learn faster, we can use less power. It uses maybe 100, maybe 1,000 times less power. We're not sure yet. And one other thing that it can do is it's really good at creating random numbers. And random numbers are actually shockingly hard to create ourselves. If you go online and you're like, I want a random number generator, they're not actually that random. So sometimes they will just use a seed number, which if you're using a seed number, then there's something that all these numbers go back to, so it's not totally random. Sometimes it will take the amount of time it took you to click the button. So it'll measure that time of your button click, and that will be the seed. So it feels random because from button click to button click, it's different, but yet it's still measuring off of that one thing. Where these guys can create truly random numbers. And you might be saying, Dr. Erica, why do I care about a random number? You might not care about a random number, but I'm pretty sure all of the adults do care about random numbers, because anytime we've ever bought something off of Amazon or online, we have had to put our credit card information in. And I don't want anybody having my credit card. That's kind of precious to me. And it's probably precious to you if all of your allowance is on your credit card. Well, all of these online guys, these retail places, they actually take that and they encrypt it. So they put it into a whole bunch of random numbers so that it's really hard for somebody who's watching the data go by pick out your actual credit card information from that, because it's encrypted. We've put it into this cool code. But if you have a big enough computer that can work fast enough or is smart enough, or if you know how that encryption is generated off of the random number, you could actually decrypt it and steal that credit card information, and nobody wants that. So one of the things that these computers can do is create truly random numbers, and that's like kind of amazing. We've never done it in the history of humanity. So these quantum computers could do it as we get to it. Now, we don't have like a necessarily working quantum computer, and when we do get them, it's not going to be the computer like I'm going to open up my laptop and it's a quantum computer. It's not for emails. Quantum computing is really for like, I need to do some really hard math problems, or I need to get a really good encryption because I'm about to send some like World War III inducing information. I want nobody to know about it. So that's what our quantum computers are going to be. Probably never going to be in your house, but it's still pretty cool to think about. And today we are actually going to entangle some Printout photons as our little quantum number generator to create our own random numbers. So what you need for this project is you need some craft magnets. Ideally you'll have 8. I have 6 today, but we will have a workaround for that. You need some sort of plastic cup to shake things around in. You need a Sharpie, and then you need our random number generator printout, which came in our email. All right, and we've got a top-down view so you guys will be able to see what we put on our random number generator. So the first thing that you're going to do is with your craft magnets, you're actually going to take sets of 2, and we are going to entangle 2 photons. We won't know which photon will be spin up, or like a 1, or which photon will be spin down, or like a 0. They'll be entangled, they'll be together. We'll have 1 up and 1 down, but until we look, we'll actually have no idea what that is. And the way we can do that is if you take your 2 magnets so that they're sticking together and they're happy, so not this way where they're repelling each other, you want them together. You're just gonna open them up like a sandwich, and on one of them, we will draw an arrow for an up arrow, and we'll write up because you might be like, Dr. Erica, an up arrow and a down arrow look kind of identical when you don't know which way is up. So we'll write the up arrow, and the other one, we'll put a down arrow and we'll write down on it. And now I have a photon, a set of photons that I can put together. One will be up, one will be down. I'll have no idea which one it is. So I have 1 entangled photon that I can use to generate a random number. And we're just gonna repeat this process till we have as many magnets as you have, or 4 entangled photons, which would be 8 magnets. So again, I'm gonna write up with a little up arrow on one, and down with a little down arrow on the other. And then I will let those guys come together as well. All right, so I only have 3 sets, but that's okay. We should be able to re-entangle our photons to get that 4th one. And so now I have these 3 entangled photons, and what we're gonna do is we are gonna put it in our cup, and we'll just shake our cup around like this. And we're gonna open this up so we can't see the answer, all right? So I'm gonna open it up so we don't know what it is. I'm gonna put this guy over here. I could send this to a completely different lab. I could send this halfway across the world, and when somebody flips this over, I'll know. If somebody peeks, I'll know, because this one will instantly flip. Right now, I'm not sure if this one's up or down. Is it up? Is it down? I don't know. Maybe it's some superposition of both. We're not sure. Once I flip it, I know. And if I know this one and these guys are entangled, then I know that one really quickly. So this is also a good way to see if anybody's eavesdropping or sneaking in onto your secure communications. So you're gonna keep doing this, and we're just gonna get all 3 of ours together. I only have 3 that I can do. Hopefully you guys have 4. And what I could do is I could actually snag back one of these, and I could do that here. I could shake this one as my 4th one. All right, so now I have a whole bunch of these magnets. I still don't know what they are. If you have a partner, you could do this with a partner, and they could have them, and you guys could figure out what numbers you have. But what we're gonna do is we're gonna slowly flip these over, and here I have a down magnet. So I'm gonna just draw the down arrow so I know. So I have down, and I have an up arrow right here. Fabulous. A down arrow. And then last I have, ooh, an up arrow. Now you might be saying, Dr. Erica, how in the world does this help me? I have a whole bunch of arrows. I know, it's kind of silly. So the way that this works is in real computers, we have all these tiny magnets, and if they're pointed in one direction, they're up, and if they're pointed in the other, they're down, similar to what we have here. And what we're gonna do is we're just going to assign a 0 or a 1 to that up or down. So the downs are 0, so I can go in and I can fill in 0, 1, 0, 1. And this is called binary. It's called binary because there's only 2 states. We're either up or down. We're either 1 or 0. We no longer have this smorgasbord of states we don't know. We flipped them over, now we know. And we have this number 1010, and you can look on this chart to find out where that's at. And for me, that's the number 10. Now, if we keep doing this, we'll get another random number, and we can string these random numbers together to get an even bigger random number, which is kind of cool. So like maybe right now I have sort of 13 and then 10. So I could have a 1310 as part of my random number encryption code. And this is just one of the things that these quantum computers that won the Nobel Prize in 2012 will be able to do really, really well. And it's an impact on our lives that we don't see day to day, like some of the other Nobel Prize winners that really do impact our lives. Like, for example, I really love that I can plug my cell phone in every night and it charges itself back up. I don't ever have to swap out the batteries. That is like in my face, amazing Nobel Prize science. This one is gonna really change the way we do mathematics, change the way we do science, change the way we encrypt things. But for us, we don't see that day to day, but it's still pretty amazing. So I would love to see what numbers you guys generate as your random number strings. And I can't wait to see how you guys do this project. Make sure that if you do it, you cut out your little wedge of your Nobel Prize and you paste it on so you grow your Nobel Prize as we go through this Nobel Prize winning unit. And check out our other videos for our Nobel Prize winning science. We have a lot of really fun science that we are doing in our Nobel unit. Thank you so much for joining us, and we'll see you tomorrow. Have a good day.